Richard Feynman's journey into the world of physics began in Far Rockaway, New York, where his inquisitive mind was nurtured from a young age. His passion for science was evident early on, leading him to the Massachusetts Institute of Technology and later to Princeton University for his graduate studies. But it was during his time at the Manhattan Project, where he contributed to the development of the atomic bomb, that Feynman's unique approach to problem-solving began to shine. Post-World War II, Feynman shifted his focus to academia, joining the faculty at Cornell University. Here, he started delving into the enigmatic world of quantum mechanics, a field that was still in its infancy and shrouded in mystery. Feynman's work during this period set the stage for some of the most significant breakthroughs in physics, revolutionizing the way we understand the behavior of particles at the subatomic level. What truly set Richard Feynman apart was not just his brilliant mind, but his extraordinary ability to demystify physics. He believed that the essence of physics was not about complex equations, but about understanding the principles that govern the universe. Feynman's approach was rooted in intuition, imagination, and a deep curiosity about how the world works. His lectures became legendary not only for their clarity, but also for their ability to inspire and engage. Feynman had an unparalleled talent for explaining intricate concepts in simple, relatable terms. He often used everyday examples and thought experiments, allowing students and enthusiasts alike to grasp the fundamentals of physics without getting lost in mathematical abstraction. This unique approach extended to his research as well. Feynman was a firm advocate of the idea that if you cannot explain a concept in simple terms, you don't truly understand it. This philosophy drove him to find new ways to visualize and conceptualize problems in quantum mechanics, leading to some of his most significant contributions, which we will explore next. One of Richard Feynman's most revolutionary contributions to physics was the invention of Feynman diagrams. These diagrams, simple yet powerful, provided a new way of visualizing and calculating interactions between particles in quantum field theory. Imagine replacing pages of complex calculations with intuitive, easy-to-understand diagrams. This was the genius of Feynman's method. Feynman diagrams represent the interactions of subatomic particles as paths in space and time. Each line and vertex in these diagrams tells a story of particles colliding, transforming, and emerging. They allowed physicists to visualize processes like the scattering of electrons or the creation and annihilation of particle-antiparticle pairs with unprecedented clarity. The impact of Feynman diagrams was profound. They not only simplified calculations in quantum electrodynamics, but also provided deep insights into the nature of particle interactions. Their introduction marked a significant shift in how physicists approached problems in quantum mechanics, making the field more accessible and opening up new avenues for research and discovery. Richard Feynman's legacy extends far beyond his contributions to quantum mechanics. He left an indelible mark on the world of physics and education. His textbooks and lectures, particularly the Feynman Lectures on Physics, continue to be a gold standard for teaching and understanding physics. They encapsulate his unique ability to make complex concepts comprehensible and exciting. Feynman's influence went beyond academia. His playful curiosity and enthusiasm for science inspired countless individuals to pursue physics and embrace a scientific way of thinking. He became a cultural icon of sorts, known for his adventurous spirit and storytelling prowess, making him one of the most recognizable and beloved figures in science. His impact is also evident in the advancements of modern physics. Feynman's work laid the groundwork for developments in quantum computing, particle physics, and our understanding of fundamental forces. He showed us that the pursuit of knowledge could be a journey filled with joy, wonder, and endless curiosity. As we conclude our exploration of Richard Feynman's life and contributions, we are reminded of the profound impact one individual can have on the world of science. Feynman changed the way we understand quantum mechanics, not through complex mathematics alone, but through intuition, imagination, and a deep passion for explaining the wonders of the universe. Richard Feynman's story is a testament to the power of thinking differently, of breaking conventions, and of the sheer joy of discovery. He taught us that the beauty of science lies not just in its complexity, but in its simplicity and the clarity with which it can be understood and shared. Thank you for joining us in celebrating the life and legacy of Richard Feynman, a true pioneer who showed us that the world of physics is not just a realm of equations and theories, but a world of beauty, mystery, and endless possibilities.